Good day, Maxi students, and good day, grade 8 students. For today, we're going to discuss about the surface area and volume of solid figures. Okay, so the past lessons that you had, so the perimeter and area of a plane figure, let's say a shape, a circle, a rectangle, you will apply all of those formulas, all of the concepts and ideas that you've learned into our topic for today. So for an introduction, we have here a cube. Okay, so the cube has been dissected and it's been separated into like different parts, and it formed kind of like a cross figure. Okay, so the first thing is we want to know, or you want to find the surface area of one of the squares. Okay, so that just means the area of one square. Okay, so what's the formula for finding the area of the square? So that's A is equal to S squared. And if we substitute the value of S, which is 19 centimeters, so that's going to be 19 centimeters squared. And that's going to be 361 centimeters squared. Okay, so now that we got the area for one square, we want to know the area of the entire cube, the surface area of the entire cube. So since there are 6 squares, okay, so since there are 6 squares in our figure here, we simply have to multiply 6 to S squared in order to get the surface area, the surface area of the cube. Okay, so that's going to be 6S squared. So that's going to be, the surface area is equal to 6 times 361. We got that from the value of our area here, of our S squared. So that's just going to simply be, the surface area is equal to 6 times 361, and that's 2,166 centimeters squared. Okay, so the area of one square is 361 centimeters squared, and the surface area of the entire figure is 2,166 centimeters squared. Okay, so if you want to know the surface area of any type of figure, we just need to decompose it, or we can just like take it apart. Okay, so if you don't know the formula for the surface area, don't worry, you can take that thing apart, and then from there you can recreate the formula. Okay, for example, we want to know the surface area of a cylinder, so it's a bit long. Okay, so the surface area of a cylinder is given here at the bottom. SA for the cylinder surface area is equal to 2 pi RH plus 2 pi R squared. So where did this formula come from? Where did this surface area formula come from? So just like what we did in the cube figure right here, we decomposed the formula and we got the formula from decomposing the figure. And from here, we have 2 circles, okay? And we all know that the area of a circle is equal to pi r squared, okay? So it's equal to pi r squared. And if you add those two, you get 2 pi r squared. So that's why there's a 2 pi r squared here on our formula for the cylinder. And where did the 2 pi RH come from? Okay, so the 2 pi r, okay, so if you remember, the formula for the circumference of a circle is actually 2 pi r. Okay, so if it's 2 pi r, then imagine that this is the side, okay, this is the side of the circle, that when you kind of like roll it out, okay, so if you roll this lateral surface area, okay, so the lateral surface area is kind of like the area on the sides, okay, and base areas are the areas on the top and on the bottom of the cylinder. Okay, so if you roll out the lateral surface area, this is the measurement of its side. So this is the measurement of its side. So it's 2 pi r, which is the circumference of the circle of the base circles, or the base of the cylinder at the top and at the bottom. Okay, and where did we get the h? So h is simply the height. Okay, so that's the height of the cylinder, and if you multiply that to get the area, okay, the area of this entire lateral surface area, you get 2 pi RH. Kind of like when you're multiplying rectangles, okay, to get the area of a rectangle, you multiply the length and the width. Okay, so that's also what you do with this cylinder. To get the lateral surface area, you multiply the area here at the top, okay, 2 pi r. I mean the side measurement here at the top, which is 2 pi r, and the side measurement here on the top to bottom, okay, on the vertical side, which is h. Okay, so that will be 2 pi rh, and that's where we got the 2 pi rh on our formula for the cylinder. So now, okay, so now that we know about surface area, we want to know more about volume. Okay, so what we know about surface area is it's the area of any solid figure. Okay, so it's the entire or the totality of the area of any solid figure. So if we have here a cylinder, so if you want to know all of the area, okay, that envelops a cylinder, so that's the surface area. Okay, now we want to know the volume. So the volume is the content. Okay, so it's the content of any solid figure, of any three-dimensional figure. Okay, so we are three-dimensional beings, so the amount of blood or liquids inside of our body, okay, so that's a volume. Okay, so we measure that in volume, in cubic centimeters, in cubic liters. Okay, and also, okay, so there are so many applications of volume in terms of in the medicinal sciences, in engineering, and chemistry. Okay, so we use volume a lot. For example, guys, we have here a figure that we want to find the volume of. We have here kind of like a container, a rectangular prism container shaped. Okay, so a container, and we want to know the area. Okay, we want to know the volume of the water. Okay, of this water here. Okay, and we know that the height of the water is 4 meters. The width of the container is 2 meters, and the length of the container is 6 meters. And we have here an additional height space. Okay, so this is the area of this empty space here above. Okay, so it's 3 meters. And if you add 3 and 4, so you get a total of 7 meters for the height of the rectangular prism. So first we want to know the volume. Okay, we want to know the volume of the water inside. So the volume of the water, we just simply have to multiply the length, the width, and the height. Okay, but what height are we going to use? We're going to use the height of the water, because that's the one that we need to find. Okay, so that's going to be, what's the length? So that's 6 meters times the width, which is 2 meters, times the height, which is 4 meters. Okay, again, we're multiplying for the water. Okay, and let's say we want to know the volume of the entire container itself. So same formula, we need to find the length, the width, and the height, and that's also the same for the length and the width. So that's going to be 6 meters and 2 meters, but the height of the container is not 4 meters, it's not 3 meters, but it's 7 meters. Okay, this one, because it's the total height, and that's what we want for the container, the total height of the container. So that's 7. Okay, so 6 times 2, that's 12, and 12 times 4, you get 48. Okay, since the unit here is meters, we're going to use meters, cubic meters. Okay, so this is the volume of the water inside of the container, 48 cubic meters. Well, how about the volume of the container itself? So that's going to be 6 times 2, that's 12, and 12 times 7, that's going to be 94. Okay, so that's going to be 94 cubic meters. Okay, so this is the volume of the container. So very easy. Okay, so now guys, let's discuss how to get the formula for the surface area and the volume of any type of solid figure. Okay, of the different types of solid figures that we have. Okay, so the first one that we commonly know is the hexahedron. Okay, so the hexahedron, its more common term, or the most common term that's used to identify a hexahedron, is a cube. Okay, so a cube, as we all know, is a solid figure that has all of its sides that are congruent. Okay, so for example, here we have the formula for the surface area, okay, of a cube is 6s squared, and we have shown before, okay, so we have seen before why it's 6s squared. Okay, so each of the faces of the cube has a area of s squared. Okay, and since there are 6 faces, so since a cube has 6 faces, we multiply that by 6, and you get 6s squared. Okay, So that's the formula for the surface area. And for the volume, so that's S cubed. Okay, the volume of a cube is S cubed. V is equal to S cubed because the given, okay, let's say we're given a side measurement, let's say it's 5, okay, so simply 5, okay. So if it's 5, then you have to multiply 5 3 times, or you multiply 5 3 times to itself to get the volume, okay, because since the side measurements are the same in all of the sides of the cube, okay, so they're all the same, and therefore that's how we got the formula V is equal to S cubed. Okay, so same goes with the rectangular prism. We're given here the solid figure. Okay, so it's called a rectangular prism, and we want to know the surface area of the rectangular prism. Okay, so it's given by the formula SA is equals to 2 length times width plus 2 width times height plus 2HL. Okay, so where did that 2 length times width come from? Okay, so we have here length times width. Okay, so that's the bottom, and if we have a bottom part here, then we have a parallel top. Okay, we have a parallel top face of the rectangular prism that we have on this figure. Okay, so that's where the 2LW comes from. One length times width at the bottom and 1 length times width at the top. Then where did we get the 2 times width times height? Okay, so if we have here a width, okay, and then a height, okay, so that's the width and the height here. Okay, if this is 1, then it has another parallel face at the back. Okay, so that's where we got 2 width times height. And then lastly, we have 2 times height times length. Okay, so that's height. Okay, this is height. Okay, so this is also the height, and this is also the length. Okay, so we have this surface right here. And of course, it's a parallel. There's another parallel face on the other side, so that's where we got 2 height times length. Okay, so that's how we got the surface area of a rectangular prism. So how about for the volume of a rectangular prism? You simply multiply all of its measurements, or the length, the width, or the breadth. Okay, sometimes we call the width as the breadth, and the height of the rectangular prism. Okay, so there you go, and we get the formula for the volume of the rectangular prism, which is length times width times height. Okay, so the formula for the surface area of a sphere is given by the formula S is equals to 4 pi r squared. Okay, so that means you have to multiply the circumference, okay, or the area of a circle pi r squared 4 times to get the surface area of a sphere. Okay, and then the volume, okay, the volume of a sphere is given by the formula 4/3 pi r cubed. Okay, and then we have the cylinder. So for the cylinder, we already discussed the surface area of a cylinder, which is 2 pi r squared plus 2 pi rh. Okay, so this is the 1 pi r squared. Then at the bottom we have another pi r squared. That's why you got 2 pi r squared and the 2 pi rh. Okay, so if you flatten the lateral surface area, or the side area, or the entire measurement of the side area of a cylinder, you get the height and then the circumference of the circle, which is 2 pi r, and that's where you get 2 pi rh. And of course, to get the volume, okay, to get the volume of a cylinder, pi r squared h, so that's one base. Okay, so that's the circular base pi r squared, the area of the circular base multiplied by the height of the cylinder, and that's the entire volume. Okay, so that's very logical. Okay, so there you go, pi r squared h, to get the entire content of the volume of a given cylinder. Okay, so for the volume or for the surface area of a cone, we have the formula. We're given here the formula SA is equal to pi r squared. Okay, so this is the circle, that's the pi r squared, plus pi r, okay, pi r multiplied by the square root of r squared plus h squared. And then we have the formula for the volume of a cone, so that's 1/3 pi r squared h.